right, so for today's science lesson, let's think back to our energy stations that we did yesterday. What type of examples of energy did you observe yesterday in our energy stations? So what's one of them, Olivia? Okay, what about the car?
You had to pull it back and it just went.
Okay, so we had the pullback car, and so when we pulled them back, what happens?
They go.
They went. Very good. All right, Harper, what else?
Hand crank flashlight and.
Okay, so what about the hand crank flashlight? How did you observe energy with that?
You have to crank it. You have to use the rotation.
Okay, so we used the crank and rotated it, and then what happened? It lit up. Very good. All right. What's another example, Alexis? Okay, so how did you observe energy in the remote?
How you had to put batteries in, and whenever you press to turn on, you have to turn on.
Exactly. Very good. Any others? Olivia?
Did somebody already say the windmill?
No.
The windmill that we did?
Okay, so what about the windmill? How did we observe energy with it?
They'd spin it really, really fast, and then the red light would come on.
Exactly. Very good job. All right, so now let's think about the patterns. Did you notice any patterns between the different examples? What did we use to observe energy? How did we know that there was energy, Jaden?
We saw it with our own eyes.
We saw it. What are some other ways that we knew there was energy besides what we could see?
It worked.
What do you mean by it worked? How did you know it worked?
Like, if there's energy, it would work like the...
Okay, so how did you know it worked? Jaden said we used our eyes. What else did we use to know if things worked or not? Yeah, we used all of our senses, right? There were a few of them that we could hear. We could hear the pullback car. Okay, that was one that you could also use your ears. The wood block and the sandpaper, you could hear it.
Things too.
Uh-huh, exactly. So we used our senses to observe. What else? Jaden? Was there movement?
Yeah. Yes.
Yeah, most of the things had movement. So because we looked at a lot of different examples of energy, there were some similarities, but there were a lot of differences too, weren't there? Okay. So thinking about the indicators of energy. Do you remember what the indicator of energy was? We talked about two different things. We talked about the source of energy, and we talked about the indicator of energy. What's the source of energy in this windmill? Where's the energy coming from, Jaden?
The wires and the light.
Yeah.
And the tire.
Yeah. From the blades that are turning? Yeah, so the spinning motion, then that travels through the wires, and that's the source. What's the indicator? How do we know energy is present?
Because the light's glowing.
Yeah, because the light came on, exactly. Okay, so in the remote, what was the source of the energy? Where did the energy come from, Jacob?
From the wind. Wait, what are we on? The remote. Okay, from the remote.
What did the remote have to have in order to work? Batteries. So the source is the batteries. And what's the indicator of energy, Dylan?
The indicator of energy is when you put batteries in.
The batteries are the source.
The indicator means when it you can turn on stuff.
Yeah, when it worked, when it turned on the television or changed the channel, whatever we were using it for. Very good. All right, so the pullback cars, we said they had some little gears in them that got tension. So the gears would be the source, you moving it back and pulling the gears backwards. What's the indicator of energy? How did you know energy was present, Brayley? What did they do?
Because they moved.
Because they moved, exactly. Very good. How about the hand crank flashlight? What's the source of energy, Ansley?
The crank.
The crank. When I crank, it comes on. What's the indicator of energy, Olivia? How do we know there's energy present?
Because the light would turn on.
The light turns on, exactly. Very good. All right. So I'm going to ask you about some other examples of energy. So if I have a light, just a regular light, what's going to be the indicator that there's energy present in a light, Owen?
The light would turn on.
Yeah, the light comes on, it shines, right? Okay, what about a heat lamp? Have you ever seen a heat lamp like would be used for baby animals or something?
Yeah, my animals have them.
Okay, so how would we know that there's energy present with a heat lamp? There's two different things. What are they, Alexis? Okay, the light will come on. What else, Jacob?
The heat.
The heat. It's going to start getting hot. Very good. How about a refrigerator?
You feel it getting cold.
Yeah, you're going to feel it getting cold.
And the light would be on.
Okay. Usually there is a light. You're correct. What about a radio?
You'd be hearing it.
Yeah, you can hear it. The music will start to play, right?
Yeah.
Okay. How would I know if an outlet was working if I plugged in a phone charger?
Because your phone would be charging.
Yeah, you could see that the phone was charging.
When your phone turns on and it has the thing that says. That looks like a zap thing.
Yeah, exactly. So, thinking about what we just talked about, all those examples I gave, and you can come up with some of your own. Which one of those have some things in common? Jacob?
They all have a light.
Okay, a lot of them have light. Owen?
All of them you can tell, all of them in a way you can tell how it's emitting energy.
Exactly, you can tell how there's got to be some type of indicator to tell us that there's energy. You're exactly right. Olivia?
A lot of them make noise.
Okay, a lot of them we can hear. Very good. Can we hear a refrigerator sometimes?
Yeah.
Yeah, besides just feeling that it's cold, when the compressor kicks on, you can hear it, right?
Yeah.
Okay. All right, Brayley?
Sometimes when you leave the fridge open too long, it will start making a noise.
You're exactly right. Some of them have like an alarm type thing on them.
Noise my mom so bad.
All right.
Ours don't have that because I've opened mine just to get like the pizza rolls out of there or something and cook them. And I left it open when I was putting them on a tray, and it didn't do anything. It just sat there.
Some refrigerators have an alarm like that and some don't.
Ours does.
Okay? So we've talked about some of the things that they have in common and that make them kind of the same. So how could we group them? What do you think? We might group those categories that we talked about. What's one way we might group them?
Well, we could do all light sources.
Okay, light sources. Very good. That would be a perfect category. Light. What would be another? Could be another category. What might this go in?
Sound.
Okay, sound could be a category. What else? Movement. We got light, we've got sound, we've got movement or motion. We talked about heat lamps, refrigerators, air conditioners, heaters could fit in this category. Heat. Okay, temperature. All right. Is all energy electricity?
No.
Give me an example of what a type of energy that would not be electricity, Amy.
Food and rest.
Okay, what do you mean by, get a little bit more specific than that?
Like when you sleep, you get energy, and when you eat, you get energy.
So how would we see that energy?
In your feelings.
In your play motions.
In your body movement, right?
Yeah.
Okay, so we have energy, and Amy's right. We get energy by the nutrients, the food we eat, and by resting our body. All right. So we've already been talking about this. We talked yesterday about what energy was, and we've been talking about indicators of energy. So here's just your formal definition. Indicators of energy show the presence of energy. So they show that there's some type of energy happening. So it might be the sound, it might be light, it might be temperature, it might be motion, all those things we've talked about. So, what would our classroom be like if we did not have energy?
Dark.
Dark. What else, Jaden?
We wouldn't be able to. We have to do all our work either like on paper.
Yeah, we wouldn't be able to use the Chromebooks, would we?
Yeah.
Okay, so it'd be dark. Everything would have to be on paper. There wouldn't be any Chromebooks or any other kind of technology. Christopher?
Be quiet.
Be quiet. Okay. Brayley, you have another one?
Don't know when bathroom breaks are and stuff.
Oh, yeah,
Alarms.
our alarms wouldn't be going off. Ansley?
So, what Rayleigh said, that would mean that, like, we wouldn't have, like, good schedules, like, we wouldn't know when it would be lunchtime.
Okay.
When we have to sleep.
All right. Good thinking. Keith?
I mean, you couldn't do paperwork because you wouldn't have anything to print the paper with.
Oh, you're right. We wouldn't be able to make copies, would we?
No, like, just a plain piece
So,
of paper.
yeah.
And the teacher says, what's 5 times 8?
Right. It'd just have to be plain pieces of paper. Good thinking. Olivia?
Well, like, you would, like, kind of like Braille's, you wouldn't know when it's, like to do stuff.
Yeah.
Because, like, the alarms.
Right. Do you think energy makes our lives easier?
Yeah.
Absolutely. Justice?
Can I say 2 things?
Sure.
We wouldn't be able to hear on the intercom.
Mm-hmm.
And, we wouldn't be allowed to go virtual because you couldn't play stuff.
Exactly. All right, Amy?
The air system.
Yeah, heating and air. Who would like to be in school with no heat during the wintertime or no air conditioning in the summertime? Whew.
Oh.
It might get miserable sometimes, wouldn't it?
Yeah.
Okay. Christopher?
I'm just saying we probably wouldn't be able to feel all the heat and the coldness and do anything because if we had no energy in the classroom and we're already in here, then that means we wouldn't have energy and we couldn't do anything. So we'd just be like,
Okay.
true.
So we'd have to have energy too, just like we need electrical energy. Our bodies have to have energy too. So we would be a lot different if we didn't have energy. You're exactly right. All right, Keith?
We wouldn't know when there's a fire and stuff like
Okay.
that. If it's like,
We wouldn't have fire alarms.
Couldn't you
Okay.
hear when
How else
No, we
would we have what would we have to rely on if we didn't have fire alarms?
Someone yell at us. There's a fire.
someone would like have to
slow it down.
breathe.
Yeah, we'd have to have somebody alert us. What could we use?
The senses.
Our senses, like our smell and
If the
things.
lights were off and nobody was making any noise, couldn't you hear like the flames and stuff?
You might could. You might, depending on how hot it was. Amy?
We couldn't cook the food.
Yeah, we wouldn't be able, the cooks wouldn't be able to just pop the food into the oven or keep it cold in the refrigerator. There'd be a lot of things that were different. All right, so Brayley, last thing, and then we're going to talk about another question.
Can I say two things?
Sure.
Some countries have to do with this,
Mm-hmm.
and we wouldn't be doing that right there.
You're exactly right. Our projector wouldn't work. And Brayley made a very good point. There's a lot of places
Yeah, there is.
that don't have the electrical energy like we have. So we're very blessed. We have a lot of things that...
I think it's because we're in a bigger state.
All right, so let's talk about this question now. At the energy stations yesterday, when did things seem to have more energy or less energy?
I have no idea. I was.
What are you thinking, Olivia?
Like once we used it with our hands instead.
Okay. So how about the cars? What did it take for them to have more energy?
Pulling it back farther.
Yeah, the further we pulled it back, then the farther and faster it went. Dylan, please stop. Okay. Owen, do you have another example?
Well, I made but I made an observation.
Okay.
That if you pulled back the car too far, that it wouldn't go as far.
Oh, Owen made a interesting observation. He said if you pull the car back too far, it wouldn't go as far. Did anybody else notice that?
Once I pulled my car
Yeah.
back really far, it would just do circles and circles, and then it would just keep on going.
Right. Kind of maxed out the capabilities of those gears inside. Okay. So, how about the remote? What about it?
Miss Wheatley. We didn't even use the TV.
Okay.
Miss Wheatley.
Yes.
TV. Magnets use energy.
It's a little bit.
Sort of, yes. It has a magnetic force. Okay. So, the remote. Did it have energy without the batteries? No. What about, has anyone ever had a weak battery in their remote at home?
Yes.
What happens?
It does easy.
Does it immediately come on or
No.
turn the channel or the volume if the batteries are weak?
No.
No, sometimes it's almost like it's glitching or something. So that's how you can know that you need to make a change in the batteries.
Yeah. One time my battery was weak. And I was watching YouTube and I tried to click a video and it took me like 15,000 tries.
Oh wow.
It made my arm sore.
Okay. Yes.
If you get a battery inside a TV remote, inside my Xbox, you can put inside my controller, and I can just press the thing on my controller and it'll turn on.
Okay. All right. Last question. This is something for you to think about. We haven't really talked about it yet. But based on what you know, what is the relationship between energy and speed? Take just a minute to think about that. What is the relationship between energy and speed? What are you thinking, Brayley?
They both make power something where the thing will work.
Okay. Amy?
You use energy for speed.
Okay. Yeah, without energy, could anything have speed? What is speed?
Energy.
It's what, Jacob?
Fast.
Yeah, it's how fast or slow something's moving. So if there's no energy, can it move?
No.
No. Okay, so we know that speed is dependent on energy. Something having speed means that it has to have energy first. Okay, what else are you thinking, Olivia?
Speed helps energy because speed, you have to have speed to make energy because like you have to be fast pretty much. Like on the windmill, you had to spin it really fast.
So the faster something is, you think that
energy
means that, so they're related that way?
each other.
Okay.
It's like peanut butter and jelly.
Okay, yeah, very good. They kind of just go together, don't they?
Yeah.
All right. Next week, that's what we're going to really talk about. Our next 2 lessons will be the effect of energy on speed, and we'll really talk about their relationship and how those 2 things work together.